magnetism and constraints on the electron. Depending on one's view of magnetism, there are two views you can possibly have. And these two views on the constraints around the electron, both views, mind you, satisfy the relationships that have been set out, but it's the way you look at them that may have different future implications on how one looks at magnetism. And when we were talking about the pull of magnetism, how magnetism pulls an iron bar, we introduced the concept of a magnetic field. This is a magnetic field. This is a pole. This is a pole. This is a view from Maxwell's second equations, and it's Gauss's law, and this is how magnetism is. It will always be joint like this, even when it comes out of the electron. And the idea of a magnet, the idea was that an unpaired electron would be like this, but as soon as you introduce the magnetic field, it will align with the magnetic field. And then these can annihilate each other, because opposites annihilate each other. You understand? You can see that they are aligned. So opposites will annihilate each other, causing that line then. So that's the unpaired electron is constrained by the magnetic field. However it spins around the atom, the magnetic moment must be aligned with the magnetic field. But there are also further constraints. Paired electrons are constrained. Let's say we have two paired electrons. They must release their magnetic moment, no matter how they release it, such that they annihilate each other. You understand? Like this, it can be a straight line, it can be like this. So as they go around the atom, the paired, no matter what they do, they must be aligned such that their magnetic moment will equal, at the end will be zero. When you add up the two vectors, will be zero, so there's zero magnetism produced. You understand? That is what is being said about magnetism right now. That's an interpretation from Maxwell's second equation. But let's read Maxwell's. Let us see what Maxwell actually said about his equation. In the book that he wrote himself, A Treatise on Electricity and Magnetism. This is what Maxwell said. To quote Maxwell, "We must therefore seek for a mode of expressing which shall not be capable of expressing too much." He's saying this idea shouldn't be capable of expressing too much. Let's continue. "And which shall leave room for the introduction of new ideas as they are developed with new facts." So I'm now going to present the second view of magnetism and constraint on the electron. We have a free electron here. That's its magnetic moment. Blue going that way, pink or whatever color that is going that way. We introduce a magnetic field, a pink magnetic field. The electron will be constrained in this manner. No matter how it spins around, the unpaired electron has to its magnetic moment has to be aligned with the magnetic field, you understand? So it will be like this. So when this vector comes out, it will be annihilated by the magnetic field. And then this one is left alone. And it will be important, you know. So, but then what happens in the electron? What about the paired electrons? The paired electrons must now have their magnetic moments, no matter where they are around the electron, such that when they annihilate each other, you understand? When the pink one leaves, it will be annihilated by the blue, and when the blue leaves, it will be annihilated by the pink. You understand? So that is a view. It's another view on the constraints of the of the electron in the magnetic field. This has nothing to do with the magnetic field. These are paired electrons. This vector of their magnetic moment must always be zero. Always be zero, whether it's you take it like this or you take it like this. The sum of the magnetic moment, the sum of the vectors has to be always zero with paired electrons. That is a major constraint on the electron. You understand? It's another way of understanding constraints on the electron, given virtual particles and loss of energy. It's another constraint which has to be looked at closely. You know, so that's it. So the dipole moment is how you take the dipole moment that will take the way you look at magnetism in the future. But both views, mind you, the vectors equal zero for the paired electrons, and the equations will be aligned, and in a magnetic field, the unpaired electrons will align themselves with the magnetic field, whichever way you look at it. So that's a sum, that's a constraint, and I hope those who enjoy science enjoyed it. It is for those who enjoy science, people who enjoy experimenting, looking at the results of experimenting, looking at theory, what are others thinking, you know. So as you said, you heard Maxwell's voice, so the rest is up to you.